All right, guys, so 13.4 is going to be really short. There's no homework for this, so I expect y'all to have this done. Monday we're going to check it, so there's no reason to lose points on this one. So we're going to start off finding the effects of change in dimension on volume of pyramids, and you can probably figure out what's going on already because we've seen it before. But let's find the volume of this pyramid, and then we'll see what happens when we mess with it. We just need the volume. So remember, volume is 1/3 area of the base times the height. And they pretty much gave us everything we need. They told us the height was 12 millimeters. And then big B we can find because it's a square base. So it'd be 18 times 18, which is 324. So now we just got to plug it into the equation and find our volume. So V is equal to 1/3 times 324 times 12. If you put that in your calculator, you should get 1,296, and that would be millimeters. That's a horrible M. Millimeters cubed. So we're going to use that volume to see what happens when we change some of the dimensions. So we've got a couple of things we're going to change. Since big B is the area of a rectangular square in this one, we're going to talk about changing the base length, the base width, and the height. So our original volume is 1,296. If we're going to double it, we're going to multiply it by 2, triple it times 3, and no change would be like times 1, but in our case, you don't even really have to do it. If you multiply 1,296 by 2, by 3, and by 1, you end up getting 7,776. Now, we did our ratios last time, so we're going to do it this times 2. So I'm going to take my new volume and divide it by my old. 7,776 divided by 1,296. If you simplify it, you get 6, which you might note is actually 2 times 3 times 1, okay? Let's do the next one. We're still starting with 1,296. We're multiplying it by 1/2. We're multiplying it times 4, and we're multiplying it times 3. So let's see, 1,296 times 1/2 times 4 times 3, strangely, gives us 7,776 again. So you can imagine that the ratio didn't change. It's still 6. Now, some people are bothered by that, but think about it. 1/2 times 4 is 2. 2 times 3 is 6, just like the top one was. Let's look at the bottom one, last one. 1,296, we're going to reduce it, so times 1/4. We're going to double it, so times 2. And we're going to double it again, so times 2. So 1,296 times 1/4 times 2 times 2 gives us 1,296. And that makes sense because think about it. 1/4 of 2 is 1/2. 1/2 of 2 is 1, so it didn't change at all. So I don't think we need to see that ratio. It's just going to equal 1. So just like all the other times we've done this, your new volume is equal to the old volume times all the changes. And in this case, there's generally going to be 3. So pretty easy stuff, guys. And by now, I mean, we've done this 2 or 3 different times already. This should be easy stuff. So the only example we have on here, it says a pyramid has a volume of 112 cubic inches. Find its volume if its dimensions were increased by 4 times the original length. So it means all the dimensions are increased 4 times. So I'm going to take 112, and guys, that's not the real bell. That's the bell in the video. I know y'all are having troubles with that. And I'm going to multiply that by 4, but I'm going to do it 3 times because all 3 dimensions were changed. You end up, when you put that in your calculator, with 7,168, and it looks like that would be inches cubed. So guys, this is a really short video. I expect you to have this done. We're also going to have the reviews and everything. And if you're watching this, remember Tuesday, we will be in a different room. So good luck, and I'll see you later.